weren't sending me stuff?
No, yeah, I was verbalizing them too. Okay. You have to like sign into 3 different things to get into this account.
Nobody has textbooks anymore.
Nope. All right, so let's start with this. So it's 3 over x minus 6 plus 4 over x plus 4.
Okay. Is that it?
Yeah, that's the problem.
Okay. What we have to do here is whenever you're adding or subtracting fractions, you got to find a least common denominator.
So x minus 6 times x plus 4, right?
Correct. And I'm particularly fond of this technique right here. Don't multiply them together, and I'll show you why. Merely list what your common denominator is going to be in each fraction. Now what goes there?
3 times x plus 4.
And the reason I like the way the denominator is written is because you can immediately tell that you haven't changed it. In other words, that is the same as that.
Right.
And that's the crucial part, to make sure you never change it when you're merely, you're changing it, but you're not changing the value of it. Now
Right.
what goes over here on the upper right?
4 times x minus 6.
Okay. Now, you know the common denominator doesn't change, so that stays like that. Simplify both numerators and combine.
Okay.
So you have 3x plus 12
plus 4x minus 24. So
as long as that is a plus, we don't need to worry about parentheses.
right.
If that's a minus, then we would need parentheses around the 4x minus 24.
Right.
Okay. So what's
so
the
then you have
numerator?
so it's going to be 7x minus 12.
And that's going to be your answer. That's the format that you want to give it in. Always leave answers in factored if possible. A factored answer is better than if you multiply those two together.
Okay, that's the simplest answer.
It is, because we never know what we're going to do with that answer. Maybe we're going to multiply that answer by x minus 6. Okay?
Right.
And if we were, well then this is better off in factored format than it is in quadratic format.
Okay.
So factored format is the format that's preferred by pretty much everybody.
Okay.
What else?
Next is x minus 10 over x minus 9. No. X minus the quantity 10 over x minus 9. Right.
Okay.
Over 1 minus the quantity 1 over x minus 9.
All right. When you have problems like this, you just kind of have to take it one thing at a time. Okay, so let's simplify that. How do I add or subtract those two numbers? What's going to be the common denominator in the numerator?
It's going to be x times, well, the common denominator is going to be x minus 9.
Okay. And what is this numerator going to be?
So it's going to be x times x minus 9.
Yeah, I forget sometimes you can't tell where my cursor is pointed. That one is still 10. You can if I'm pointing with my cursor, but if I'm pointing with the instrument that I write with,
yeah, I can't see that.
you can't see that. And then we're going to do the bottom same way. Come up with a common denominator. What's this numerator on the lower left?
1, oh, it's just x minus 9.
And there's a 1 there. So now one of the things that you eventually realize when you're working with these is if the denominator in the denominator is the same as the denominator in the numerator, then you can just cancel it straight out. In other words, I can cancel that with that. They're all the same.
Okay.
What I'm left with is x times x minus 9 minus 10 all over x minus 9 minus 1. Which
Okay.
becomes...
That becomes x squared minus 9x minus 10 over x minus 10.
Yeah, now that's an interesting problem because the numerator actually factors. This is one of the few times that I've ever seen where you can simplify it further. What's the numerator factor into?
Let's look. So it's x and x. So it has to add to negative 9 and multiply to 10.
Actually, not really. It has to multiply to 10, but subtract to 9.
Right. So it's negative 9. Wait. So it has to subtract.
Has to multiply to 10, first of all.
Multiply to 10. So it's 10. It's 1 and negative 9.
It's got to be multiplied to 10. So it could not be 1 and negative 9 because that would multiply to 9.
That's what I meant. I'm sorry. 10.
If those two numbers multiply to minus 10, then you satisfy that, and they have to subtract the 9. Well, 10 and 1 do.
Right.
Then I just have to figure out where to put the 10, and it goes with the sign of the middle term. Okay.
And then you can cancel the x minus 10.
Yeah, so I can simplify it all the way down, which I don't see very often, where you can actually factor and simplify that and come up with a factor that equals the denominator so that you can factor it further.
Yeah, okay. Well,
Okay.
so that's obviously the simplest answer.
Yeah.
Okay.
And there is a provision with that answer, and I don't know if that's important for you or not. The answer is not exactly x plus 1. The answer is x plus 1 with the provision that x cannot ever be equal to 10. In other
Right.
words,
Just in the denominator.
Right. There's a hole at 10. I'm not sure how much you've gotten into graphing these things.
Yeah. That'll probably be later in the test, but we've had to graph multiple things like
That's where you get holes, is when you can actually factor out something, but it doesn't take away from the fact that x can still never be 10.
Right.
In other words, you're always constricted by the original function.
Right.
And in that original function, x cannot be 10. So just because I factored out an x minus 10 from top and bottom doesn't make that go away.
Okay.
All right.
All right, so this next one is -3 over 7 plus 2 times the square root of 5. It says rationalize the denominator.
Okay. When you are rationalizing a denominator that has two terms like this,
You take out the radical.
multiply by the conjugate. That's what you want to do. Notice that if I multiply by 7 minus 2 root 5, I'm going to get rid of the radical sign. Whenever you have a plus b times a minus b, you end up with a squared minus b squared. Okay? Which means there's no middle term. And if there's no middle term, then I will not have a radical sign left.
Okay.
Now, I cannot multiply the denominator without multiplying the numerator by the same thing. Tell me what the denominator becomes.
49. Let me FOIL it.
Your middle two terms are going to cancel, so don't even worry about them. The only last term that's left is that times that.
Yeah. So then it would be -4 times square root of 5.
Well, remember the square root of 5 has to be multiplied by the square root of 5, so that becomes 5.
5. So it's -4 times 5, so it's 20.
Minus 1, exactly. Okay, now, the numerator, I also have to multiply. I have to distribute that -3 to both of those terms.
Okay.
And that becomes minus 21 plus 6 root 5. And that becomes...
Over 29.
Yeah, over 29. Now, you might say, well, what did we accomplish? Because we now have the radical or the irrational number in the numerator. Well, that's an excellent question. I'm not sure exactly what the answer is, but that's mathematical convention. I think
They just don't like the...
I think the answer has to do with the concept of what division is. In other words, I can break something up into 3 parts. I can break something up into 5 parts. I can even break something up into divide by half or a third. But how do you break something up into the square root of 2 parts? In other words, can I really divide 1 by the square root of 2, which cannot even be written as a fraction? So that's where math got the idea that you cannot have denominators that are irrational numbers.
I mean, I guess that makes sense.
Yes and no. There are certain irrational numbers that you can't do anything about. If I have 1 divided by pi, I cannot rationalize that.
Right.
So I've got to divide by pi. Or if I have 1 divided by e, I got to divide by e. So there's sometimes you can't do anything about it. And in all honesty, this number is no different than this number. Right there, 1 over square root of 2. Put it in your calculator. It'll be exactly the same out to 9 decimal places as square root of 2 over 2. So they're really the same number. It's just a math convention.
Why does it matter then?
Well, that's a good question. And you know what? I'm running into a lot of trig teachers where it doesn't matter. They tell their students to leave it unrationalized. And when you're dealing with trigonometry, it makes a whole lot of sense because you frequently have to take the reciprocal. So rationalizing it kind of hurts you. In other words, if you rationalize it to that and then take the reciprocal, well, then you end up with 2 over root 2, and now you got to rationalize it again. So with trig, it actually makes a whole lot more sense to not rationalize, which I love. I love that new technique, but that doesn't change anything. They still teach this concept of rationalizing the denominator. Now, if the denominator is just a flat-out square root of something, like square root of 2, pretty easy to rationalize it. You multiply it by root 2 over root 2. Well, if your denominator is some number plus an irrational number, you rationalize it by multiplying it by the conjugate.
Okay.
7 minus 2 root 5 is the conjugate of 7 plus 2 root 5. And as long as I multiply by the conjugate, I'm going to lose the root sign. We didn't have any square root sign left over there.
Okay.
All right. What else you got?
So this is solve for v, and it's 3 over 5v minus 7 over 2v equals 1.
Equals what?
1.
All right. There's two ways to go here. One, I could subtract those two fractions by finding a common denominator. Okay?
Mm-hmm.
Then I would be able to solve it. But personally, I kind of have a more favorite technique, which is by multiplying both sides by not even what would have been the common denominator. Actually, no, 10v would have been the common denominator. But notice that when I multiply both sides by what would have been the common denominator, it simplifies very quickly. What do I get?
Equals 10v. You have 30v over 5v minus
Which is
70.
That's the number 6.
Right. 70v over 2v, which is 35, equals 10v. So you have...
Notice how much easier the equation just got. Merely by doing what we did. All of a sudden it becomes a piece of cake. Minus 29 equals 10v. V equals minus 29 divided by 10. But the key is that when you have equations that have fractions in them, I would say always try to get rid of the denominators as almost a first step. It makes more sense than even trying to subtract the two fractions. Sometimes you have to do that, but sometimes it's a little quicker. In other words, I could have done that. The common denominator would have been 10v, and that would have been 6. This common denominator would have been 10v, and that would have been 35, and that would have all been equal to 1. And then I would have multiplied both sides by 10v. Maybe
This is faster.
one step further, one step more. Yeah, it's much faster if you can figure out a way to get rid of your denominators in one step.
Okay. It says if there's more than one solution, separate them with commas. There's not, right?
What did we have? No, there was only one solution.
Okay.
This is not a quadratic. Let's talk about that for a second. If I were to subtract the two, one might be tempted to say that the common denominator has to be that. But that's not true. All I need is for the common denominator to be divisible by both these denominators. So I don't need 10v squared, I just need 10v. 5v goes into 10v and 2v goes into 10v. That's all I need.
Okay.
In other words, you don't always just have to multiply the two denominators together to get the common denominator. So even if I were to do it that way, in other words, if somebody came up with 10v squared, then I could maybe see you coming up with two answers. But not really. You still shouldn't come up with two answers. But as long as you don't get into quadratics, you're not going to come up with two answers. As long as you leave the thing linear, you only come up with one answer. And what we ended up with was 10v equals, what was it, minus 29?
Yeah,
So
over 10.
There's only,
yeah.
There's only one answer. That one right there.
Okay. So these I'm having trouble with, and they get more complicated as we go on, but the word problems I always have trouble with.
Okay. Go ahead and
On Thursday.
Go ahead and try reading it. I'll see if I can grasp the whole thing. Sometimes word problems are better if you send me a copy of them.
Okay.
It depends on the word problem. Go ahead and try reading it.
A local hamburger shop sold a combined total of 369 hamburgers and cheeseburgers.
Okay.
The cheeseburgers sold was 2 times the number of hamburgers sold. This one's easy, I think. Wait.
Okay.
How many hamburgers were sold on Thursday?
Yeah. This one is easy.
So it's C equals 2H.
Okay, now what?
So how many hamburgers were sold?
First of all, it's important, Max, to recognize that you're dealing with two equations and two unknowns.
Right.
And that system of equations.
But C equals 2H.
Right.
So it's really just 369 equals H plus 2H.
Exactly.
So it's 3H.
Right. Now you
369
do
equals.
that math, you get, that's what the number of hamburgers sold was.
123.
Right. And then the number of cheeseburgers was twice that, so it must be 246. Add those together, you get 369. But the important thing to realize here is that once you get two equations and two unknowns, that's all you need to solve it. Now, the method you use to solve it can still be various methods. The two primary methods you use to solve a system of simultaneous equations is either substitution or elimination. Well, we used substitution here. In other words, we knew what C was, so we substituted that for that C. And then it's all we had to do was solve for H. Once you solve for H, then it's really easy to go back and solve for C. It's twice H.
Okay. Is there a way I can send you a picture on here?
There is. Well,
or I can share my screen?
Actually, maybe not.
I could share my screen.
You're getting that material from your computer screen, right?
Yeah.
Well, let's see. If you could somehow make a screen image and send me that. Do you know how to do that?
I'm sure there's a way.
I'm sure there's a way too. I'm just not sure I know enough to direct you how to do it. The other way you could do it, and this probably would work, is take a picture with your camera of your monitor and send it to my email.
Wait, let me just try this first, see if this works.
Yeah, if you can figure out how to take a screenshot, print, or control print screen, but then you got to paste it and paint and save it and then attach it as a file. Might just be easier to take a picture with your camera and then send it from your camera.
All right, I'll send it right now.
I'm not sure which is going to be easiest.
This word problem is, these are the word problems I'm having trouble with. I can't figure these out.
Did you send it by email?
I just texted it to you.
Okay, that's not going to be as easy because let me read it on my phone, but I don't have a real big picture here.
I can email it to you. Here, what's your email? I'm on a different computer.
Here, let me write my email. You want this in your phone anyway. Because most of the time, if you have stuff you want to send to me, send it to my email, not my phone. And send it one picture at a time. You send more than one, sometimes it's too much and it won't send if it's too big of a file.
All right, here we
Tell
go.
Tell me when it says sent.
It would let me click on it. Awesome.
You're doing this from your computer, right? From the screen, print screen?
Yeah, okay.
Okay.
I just sent it. It says sent.
Okay, cool. Let's see if this works, and if it does, you may have to tell me how you did it, because I could see that that would be valuable. Yeah, there it is.
If you click on the image, it should get larger.
Not letting me click on the image or the email.
Let me attach it. I'll send it again. I'll attach it as a file.
Let me see if I can read it. I think I can. 2 trains leave at the same time, one heading east, one heading west. Yeah, I can figure this out. Hold on. I don't need you to resend it. Let me just write it first of all so that I have the problem. So one's heading west. They leave at the same time. One's heading east. Westbound's going 80. Eastbound's going 70. How long will it take for the 2 trains to be 210 miles apart? Do not do any rounding. Okay. The master equation that governs these kind of problems.
Are you asking me?
Yeah. What's the general equation that governs distance, rate, time problems?
Distance equals rate times time.
Yeah, I remember it as dirt. Distance equals rate times time. Okay. And these can always be a little tricky when they're laid out like this. Okay, but notice that we know a few things. They want to know when the total distance is 210. Well, if I separate this into 2 equations, I got distance of train A equals the rate of train A times the amount of time that train A is going. All right?
Right.
And that comes down to 80 times the time that train A goes. And if I look at train B, its distance equals its rate times its time. And we don't know yet anything else, but which means that it's 70 times time of B. Now, the question says, when will the 2 trains be 210 miles apart? What does that tell me?
The distance.
Tells me that dA plus dB has to be 210. In other words, if dA is the distance that A travels and dB is the distance that B travels, then the sum of their two distance has to be 210. What else do I know?
You know how fast A and B are going?
What you know is that TA equals TB.
Right, because time is constant.
Well, when they are separated by 210 miles, they will have each spent the same amount of time traveling. In other words, this problem is not a problem that says train B left 1 hour later than train A. They both left the station at the same point in time. When you're asking, well, at what point in time are they 210 miles apart, they both will have traveled equal amounts of time. So definitely say TA equals TB. Now I got enough equations that I can solve for everything. Let's let TA equal TB. Let's see. So that means that dA, which was R sub A, excuse me, we know more than that. We know that dA is 80 times T sub A, and I'm going to add that to dB, which is 70, not T sub B, but T sub A, because I know that T sub B is the same as T sub A. And I know that's equal to 210. So now I basically know I've solved the problem because I have it down to a single equation and a single unknown.
Okay, so then it becomes...
Once I solve for T sub A, I don't even... What were they asking about? How long? When? Yeah, they're asking when will they be 210 miles apart. Well, that means I'm solving for T sub A. So I get 150, T sub A equals 210. So
T sub A equals 210 divided by 150.
Yeah. And
which is
that time
1.4 hours.
Yeah. And if we want to check it, well, multiply 1.4 times 80. What do you get?
1.4 times 80, you get 112.
So train A goes 112 miles in 1.4 hours. What's train B go? Multiply 70 by 1.4.
98.
Add those two distances, that's 210 miles apart.
Okay. Yeah.
And
that makes sense.
if your life depended on this, you would do this final step. If you were in a timed test, you might not take the time to do that final step, depending on how certain you are of your technique.
Right.
But it never hurts to do that final step, because a lot of times if you have time, that final step will point out math errors or things.
Right. Can you give me another one of these, just like a random one that I could just do really quickly? See if I get it.
These are tough to come up with the problems, mainly because they can vary in degree of difficulty. I had one the other day that a student where the second train left 2 hours later than the first train.
Yeah, I don't get any like that. They always leave at the same time.
Okay. Well, I can make one up with just different numbers. That train's going at 40 miles an hour or 60 miles an hour. We'll make this train go at 40 miles an hour. So how long before they are separated by exactly 100 miles?
Okay. So D equals RT. So DA equals RATA. And DB equals RBTB. TA equals TB. Our rate of A is DA equals 60 TA, and our rate of b is dB equals 40 TB. Now we're trying to find when they're 100 miles apart. So 60 TA plus 40 TA equals 100. So 100 TA equals 100. Divide by 100. TA equals 1.
Yeah, and that was kind of accidental on my part. I actually wasn't trying to come up with a whole number like that. And now that I see why, of course it's 1 hour. In other words, at the end of 1 hour, this has gone 60 miles, this has gone 40 miles. They're separated by 100 miles. But that doesn't matter. You did it exactly the technique that you need to do.
Right. Okay.
Even if they're harder, even if train B left the station 2 hours later, well, that means that instead of TA equaling TB, well, then TA
equals TA minus 2.
Right. If it left 2 hours later. TB equals TA minus 2. Yeah.
Okay, cool.
So, in other words, you can always handle more difficult type problems as long as you remember dirt and separate them down like this. In other words, you have a dirt per train, and then just see if you can get it down to one equation and one unknown. That's what you always have to do. Sometimes you end up with a system of 2 equations and 2 unknowns, and you solve those by however you need to do it. But even in that one, we had 2 equations and 2 unknowns. We used substitution to solve it.
Right.
Okay?
Okay, so this is complex numbers. It wants me to write my answer is a complex number in standard form. So it's 2 over -5 plus 6i.
Okay. Complex numbers are actually pretty easy. They're not hard at all. It's easy to add complex numbers. You just add the real part and the imaginary parts separately. Same thing with subtracting them. If you're multiplying complex numbers, you just use FOIL to multiply them. The only thing that's even mildly difficult is dividing by a complex number. And that isn't even hard because it's not really a division problem. It's a little like saying, what is 1 over square root of 2? That is not a division problem. That is a rationalization problem. We don't do any division at all. We do nothing but multiplication. Well, same thing with imaginary numbers. Instead of rationalizing the denominator, you're going to realify it. And you realify, that's my word, not anybody else's, but you realify a complex number by multiplying by its conjugate, always. Same way you rationalize an irrational number that, like 5 plus root 2. You multiply it by 5 minus root 2.
So just the conjugate.
Just the conjugate. That's all you need to remember. And of course, if I'm multiplying the bottom by that, I got to multiply the top by that. Now, simplify the bottom first, just so you see the advantages of multiplying by the conjugate.
So you get 25 minus 6 plus 6, because square root of -1 is plus 6.
First of all, recognize that that is what you would get if you had the difference of perfect squares factored, right?
Right.
So the way to multiply those two numbers back together again is to square the first one, which you did, 25. Now square the second one, with a negative sign in between. That's 36I squared, correct?
Right. I squared is -1.
Correct. So now that bottom turns into 61. And it gets realified. It's now a real number. Now, the top is still imaginary because we still have to multiply that by 2. So we get minus 10 plus 12I.
Why plus?
Excuse me, my mistake. Thank you.
Oh.
No. Just checking to see
Minus
if you're paying
12.
attention. No, not really.
Oh.
I made a mistake. But okay. Now he says he wants it in A plus BI form. We don't have it in that yet. In other words, we're looking at this. Minus 10 minus 12I over 61. That's our answer. Well, in order to put it into A plus BI form, we got to separate that into two fractions. There's the real part, minus 10 over 61. And there's the imaginary part, 12 over 61I. So this is the proper answer if he is insisting that it be in A plus BI format, which is
that
the
standard
proper,
form?
that's standard format for a complex number. As
Okay.
opposed to this over here on the right, where I have it circled, that's not quite simplified enough. That's a complex number in the numerator divided by a real number. But if I want to convert this thing to strictly a complex number, I got to separate it into two fractions. And you can always do that. In other words, it's always equal to that fraction minus that fraction.
Okay.
And sometimes you might be able to simplify this expression. I might not be able to simplify 10 over 61, but maybe I could simplify some other number over 61. So if you could simplify either one of those, you should. Now, this is the real number, part of the complex number. This is also a real number, but it is the coefficient of the imaginary number.
Okay.
So A and B are both real numbers.
Okay. Because if the imaginary number is in the numerator, then it's a real number.
Yeah, in other words, if it's something like 2 plus I over 3.
That's a real number.
Well, that's still not in A plus BI format, but I could make it 2/3 plus 1/3 I. Now that's in A plus BI format. In other words, it is already a real. This is not a real number. 2 plus I over 3 is a complex number. But complex numbers separate into their real part and their imaginary part.
Okay.
In fact, if you go to graph a complex number, this is the real axis, this is the imaginary axis. So if I wanted to graph this number over here that I have circled, I would go to 2/3 on the real, 1/3 on the imaginary, and that's where it is.
Okay. All right. So this next one, I think I know how to do it, but let's just do it together anyway.
Okay.
It's just simplify the complex number I to the 53rd.
All right. What do you think it is?
Well, how they taught me to do it is I'll immediately separate one of the i's, so it's I to the 52nd I.
Yeah, that's exactly. And you separate it, making sure that's divisible by 4. That's how you separate it.
Okay.
In other words, you don't separate it into I to the 51st times I squared. The way I do it, there's really kind of an easier way to do these. divide by 4 and make it the remainder. Well, if I divide by 4, I get 13 with a 1 remainder. That means it's the same as I to the 1th power, which is the square root of minus 1.
What do you get? If 53 divided by 4 is what?
13 with 1 remainder.
Okay.
Let's make it harder. Let's make it I to the 503rd power. Divide that number by 4, and whatever you get as a remainder is going to be what this is.
It's giving me 0.25 as my remainder.
Well, not 0.25, it's 3. In other words, if I divide 503 by 4, I know 4 goes into 500 evenly. It's 125 plus a remainder of 3.
Oh, okay. I'm sorry. Yeah, I get that.
That remainder that is the exponent. Now, let's just go through these. I is the square root of minus 1. I squared is minus 1, a real number. I cubed is minus 1 times I, so it's minus I. And I to the 4th is I squared times I squared, so that's 1. And then it's repeating. In other words, the next 4 cycles are the same numbers. In other words, I to the 5th is I to the 6th is I squared, I to the 7th is I cubed, I to the 8th is I to the 4th. So the only
because I times I is
memorize are those first 4.
Okay. So then if I have 3 remainder, then it's negative I.
Correct.
So on my question, which is I to the 53rd, you divide that by 4, which is, so it's 52 divided by 4, which is 13 with 1 remainder.
So it's this one right here.
So the square root of negative 1.
Correct.
Which is just I. You could just leave it as I.
Yes, you could. Yes.
Yeah, because it doesn't give me the option for typing in a square root symbol, so I guess it's just I.
It's just I is what that is. And it doesn't matter how big that numerator is. I could say, what is I to the 2 millionth and 1? Well, that remainder is 1.
Right.
Because 4 divides evenly into all 3-digit 100, 200, 300, 400. So here's something that's worth knowing when you're working with I, is if a number is divisible by 4, is this number divisible by 4?
Yes.
Because the last 2 digits are. That's all you need to know.
Oh, is that true?
Uh-huh. In other words, this number also is divisible by 4. The only thing I need to know is the last 2 digits are divisible by 4.
Okay.
If it's 25342, that's not divisible by 4 because 42 is not.
Okay.
And probably the only time you really need to know whether numbers are divisible by 4 is when you're dealing with complex numbers, where you're trying to convert, I to the 1107th power. Well, that remainder is going to be 3, because I know that 4 divides into 1100 evenly, which means it divides into 1104 evenly. So I got a remainder of 3. So that's going to be I to the 3rd.
Okay. All right, so this one says, write the quadratic equation whose roots are negative 5 and 1, and whose leading coefficient is 1.
All right. If the roots are negative 5 and 1, what are the factors?
Factors? -5.
No, let's go backwards here for a moment. Let's take this problem right here. We factor it, right?
Mm-hmm.
Becomes x minus 5 times x minus 2 equals 0. Then we make the assumption that if two numbers multiplied together equals 0, well then one of them has to be 0. So we go back, and to find these zeros, we set that factor equal to 0. So we come up with x equal 5. And
Okay.
later, when we set that equal to 0, we come up with x equal 2. So now let's work backwards. Let's say somebody gave you the problem where they said the zeros are 5 and 2. What is the quadratic? Well, you would say one of the factors is x minus 5 and the other factor is x minus 2. You would multiply them together to get this. And then if it told you that the leading coefficient had to be 1, we would have our answer. If they told you the leading coefficient had to be 2, then I would multiply that by 2, that by 2, and that by 2, and this side by 2. And I would have my answer also. So, they have told us the two zeros. What are the leading, or what are the two linear factors that those two zeros tell us?
It tells us that x is x, so there's x plus 5 and x minus 1.
Now multiply those two together. What do you get?
You get x squared plus, x squared minus x plus 5x minus 5. So x squared plus 6x minus 5.
I think it's plus 4x.
Plus 4? Oh, because it's a minus, right?
Yeah. So this would be a function whose zeros were minus 5 and 1. Now, does it satisfy the requirement that its coefficient is 1? Yes, it does. That's our answer. Had they said make sure that its leading coefficient is 3, then I would just multiply that whole thing by 3. It would be 3x squared plus 12x minus 15.
And that still gives you the same factor?
That are going to be exactly the same.
Oh, okay.
They're not going to be any different because, remember, I got the zeros by setting that equal to 0. Well, I can multiply both sides of that by 3. I still got it equal to 0.
Okay.
They'll give you this kind of problem in various disguises. They might tell you that it has a constant of minus 10. Instead of telling you that has a coefficient of 1, let's say they would have said has a constant of minus 10. Well, if you look at the function we came up with, how would I make that constant minus 10?
Multiply the whole thing by minus 10.
Not minus 10, by 2. In other words, I can multiply the left side by 2 and the right side by 2. And then I get 2x squared plus 8x minus 10. There's the constant they're referring to.
So the constant is the number part without the variable?
Yes.
Okay.
That's what that's called, is the constant. So they might give you a constant, or they might tell you the leading coefficient. They might even tell you the coefficient of the middle term is 8 or 12. Doesn't matter. It tells you what you need to multiply everything by. And the reason I can multiply everything by any number I want is because the right side is 0. So I could multiply by 2 or 20, and it doesn't change the right side. The right side still is 0.
Okay. Right, because it's multiplying by 0.
Yeah. Well, when you multiply 0 by any number, you get 0. So.
Right.
I got a 4 o'clock that I got to go to, but I might have time for one more. Depends on how complicated.
It's a find all complex solutions.
Okay.
2x squared minus 3x plus 5 equals 0.
All right. The fact they said find all the complex solutions means I'm not going to be able to factor this.
Okay.
Although, why does it look like it will factor? If I have, no, it won't. I got to use the quadratic formula. First of all, if you come up with complex solutions, you're not getting it by factoring. You're only getting it by using the quadratic formula.
Okay.
So you got to know the standard quadratic formula. What is it?
X equals b, right?
Minus b?
Minus b plus or minus the square root of 4.
B squared minus 4ac.
B squared minus 4ac.
All over 2a.
Okay.
Whatever you have to do to memorize that, do it. Because at some point, you're going to need to know that by heart. They're not always going to give it to you. Okay? And tell me in this one, what is A, B, and C? What's A?
A, 2.
What's B equal to?
Negative 3.
And what's C equal to?
5.
Since I'm out of time, I'm not going to go through the arithmetic, but I don't think you need me to. In other words, when you plug in A, B, and C into that, you're going to come up with 2 answers.
A plus answer and a minus answer.
Exactly.
Okay.
Well, you're going to come up, this plus or minus pretty much guarantees you're going to have 2 answers. The only time you won't have 2 answers if that's equal to precisely 0. That's called the discriminant. And in this case, it's 9 minus 4 times 2 times 5. It's not equal to 0. So you're definitely coming up with 2 answers. And since the discriminant is negative, you're coming up with 2 complex answers. Complex answers always come in pairs, never by themselves.
Okay.
Only time you get a complex answer is if this discriminant is negative. And if it is, then you're going to have a plus and a minus answer. So you will always have complex answers in pairs.
Okay.
And whatever you get, you know how to turn minus 8 into a complex number?
Minus 8 into a complex number. That's...
What is that?
8i. No.
Well, it would be root 8 times I, but then root 8 actually becomes 2 root 2 times I.
Okay.
But the way, here's the key. If I said, what's the square root of minus 121? Always do it this way. Take out the minus 1, leaving 121 like that.
Okay.
And there's never any question, because that's always I. That's 11. So your answer is 11i.
Gotcha.
All right, Max. I think we'll be talking to one another a lot here in the next few days.
Yeah, I'll talk to you tomorrow.
Yeah, talk to you then. Have a good night.
All right, you too.